Have you ever wondered about this paradox? Why does humanity's most complex game have only two of the simplest rules, black stones and white stones, placed on a 19 by 19 grid? 1. Stones without liberties die. And 2. Whoever controls more territory wins. That's it. But these two rules create more possibilities than there are atoms in the universe. Go has 10 to the 170th power possible game states, while the observable universe contains only 10 to the 80th power atoms. This isn't just a numbers game. This is a revelation about the deepest secrets of our world. Welcome to Zen and Go, the magic of simple rules. Go might be one of humanity's greatest inventions, not because it's complex, but because it's so ridiculously simple, essentially just building blocks of 1 plus 1. Picture this. 4,000 years ago, some Chinese person picked up 2 piles of stones, drew a few lines in the dirt, and created a thinking universe more complex than modern supercomputers. This person knew nothing about algorithms or complex systems theory, yet accidentally touched upon the universe's most fundamental operating principle. This principle has a technical name: emergence. What's emergence? Simply put, it's the phenomenon where 1 plus 1 equals more than 2, when countless simple entities interact according to simple rules. The entire system suddenly erupts with completely unpredictable complex behavior. Think about computers. Their essence is just zeros and ones, where 0 means off and 1 means on. Yet the endless stacking of zeros and ones created our miraculous internet age, which in less than a century has surpassed thousands of years of human achievement. This behavior doesn't belong to any individual 0 or 1. It's entirely new intelligence emerging from collective interaction. And Go happens to be the perfect textbook for emergence. Professional Go players often say, the game has its own logic. What is this logic? Nobody can fully explain it. Because this logic doesn't exist in any single stone, nor in any single rule. It exists in the interactions between millions of stones in the historical accumulation of countless games. It's like bird flocks in flight. Each bird follows just 3 simple rules. Keep up with neighbours, avoid collisions, move toward the group centre. But when thousands of birds fly together, they paint breathtaking dances across the sky. No conductor, no blueprint. Pure compound effects of simple rules. The philosophy of liberties and its resonance with modern science. Now let's dive into Go's core concept: liberties. In Go, every stone needs liberties to survive. Liberties are the empty points adjacent to a stone. Up, down, left, right. When all of a stone's liberties are blocked by the opponent, that stone dies and must be removed from the board. This concept is fascinating. 4,000 years ago, the Chinese described what modern complex systems theory calls resource competition and living space, using the most intuitive understanding. Think about any system in the real world. A startup needs funding and market space to survive. A species needs food and habitat to thrive. Even an idea needs attention and channels to exist. When these liberties are cut off, the system collapses. But what's more magical is that liberties in Go aren't static resource allocation. They're dynamic ecological balance. A seemingly dead stone might suddenly come alive under special circumstances. A seemingly safe group might instantly collapse under an opponent's clever attack. Isn't this exactly how our real world works? Look at Silicon Valley's startup ecosystem. On the surface, every company competes for the same resources: talent, funding, user attention. But actually, the entire ecosystem is dynamically balanced. One company's success often creates new opportunities. For others, saturation in one field catalyzes entirely new tracks. Just like life and death problems in Go, every Silicon Valley company is solving an eternal survival puzzle. How to find your own eye space, your foothold, in a resource-limited environment, ensuring you won't be killed by competitors. The most interesting part is what we discovered when we tried teaching computers to play Go, another layer of emergence. In 2016, AlphaGo's victory over Lee Sedol shocked the world. But what was truly shocking wasn't that a machine beat a human. It was the kind of intuition the machine displayed. AlphaGo's move 37, later called the Hand of God, seemed completely unreasonable at the time, violating all traditional Go theory. Professional players called it a mistake. Go software gave it only a few thousandths of a % chance of success. But ultimately, this move proved to be the key turning point of the entire game. What does this tell us? It shows that through deep learning from thousands of years of human game records, AlphaGo developed a kind of game sense that transcends human understanding. This sense wasn't programmed in. It naturally emerged through countless self-play sessions. Even more amazing is AlphaGo Zero. It needed no human game records at all, learning Go purely through self-play from scratch. After 40 days, it surpassed all human players and previous AI programs. What does this mean? It means the wisdom contained in Go might far exceed humanity's 4,000 years of exploration. Those patterns and theories we thought were Go's essence might just be the tip of the iceberg of this vast intelligence system. Just as ants don't know they're building cities, we humans might not realize that what we're exploring in Go is actually some fundamental law of how the universe operates. Go patterns are everywhere. When you start viewing the world through the lens of emergence, you'll find Go patterns everywhere. The stock market is a giant Go board. Every investor is a stone, following simple buy-sell rules. But the collective behavior of countless investors creates market patterns too complex to predict. Technical analysis, fundamental analysis. All these methods are like Go patterns, trying to find order within chaos. City planning works the same way. Nobody can design a perfect city because cities aren't designed, they emerge. People's daily behaviors, commuting, shopping, entertainment, are like stones placed on a board, ultimately forming the city's spatial structure. Those seemingly random street layouts actually reflect the collective wisdom of countless individual decisions. Even our brains work this way. Each neuron is simple, just deciding whether to fire based on input signals. But 100 billion neurons connected together give rise to consciousness, thought, creativity. Every idea we have is like a Go position, the result of countless simple neurons interacting. The universe in a game. So, next time you see a Go game, remember, you're not just looking at a game, but a miniature model of how the universe operates. From two simple rules emerging into infinite, complex variations, from individual stones to collective intelligence, from ancient games to modern AI, Go shows us the magical power of emergence. It tells us that the world's complexity isn't designed, it naturally emerges from the simplest interactions. The development of human civilization, technological progress, even the birth of consciousness, all might follow the same emergence principles. As Go, simple rules, complex results, the whole greater than the sum of its parts. If this way of thinking amazes you too, don't forget to like and subscribe so more people can understand the deep logic behind our world. Tell me in the comments, what other Go-like emergence phenomena have you discovered in life? See you next time.